Hey, in this video lesson, I'm going to teach you how to do domain and range of discrete sets. This lesson is going to go over kind of a Cliff's Notes, like a summary of domain and range. So I'm not going to go over like formal definitions necessarily, but just this is kind of like more of like a study lesson. So domain is associated with the independent variable. And we usually call this X. So in some situations, the variable is not X. It may be A, B, C, whatever. You can use whatever variable there, but the important part is that domain is independent. I'm going to refer to it as X most times because we usually use X, and that's fairly safe. But just know that it's the independent variable. And that means that range is associated with the dependent variable, and we usually call this y. And again, other variables can be used there, but we're just going to say y for the sake of this lesson. For a relation, so a relation is just a set of points. There's not really many restrictions on a relation. It's just a set of points. So anytime you can translate a graph or a table or anything into a set of points, then it's a relation. But for a relation to be considered a function, then each element of the domain must be paired with a unique, that means only one, element of the range. Graphically, you can use the vertical line test to determine if a relation is a function or not. So let's talk about that just a second. So this is kind of fancy language here. Each element of the domain must be paired with a unique element of the range. Basically, what that means, if I were to paraphrase that, what that means is that no X values or domain values can repeat, which kind of helps explain the next thing about the vertical line test. If you have a graph and you have 2 points, I'll just sketch it here like that, and I run a vertical line through the graph, then it fails. Because what that means is when I say it fails because it hits 2 points at the same time, which means that X repeated. So this X value has 2 Y values associated with it, and that defies the definition of a function. So when X repeats, the relation is not a function because it fails the vertical line test, or X is not paired with a unique value in the range. So long story short, if X repeats, it is not a function. That's kind of what you need to know, study sheet wise. So we have some examples down here. We're going to state the domain and range of each relation and then determine if it is a function or not. So I have in part A a set of points. So it is a relation. And in the set of points, we have X and Y on every coordinate point. So I can write that out actually. X, Y, I'll do one. X2, Y2, X3, Y3, X4, Y4. So domain is the set, so the little brace, curly brace, means set of X values. And I'm going to write these X values in order from least to greatest. So we have a 0, we have a 1, we have a 3, and we have a 5. The range is the set of Y values. So I'm going to write the Y values in order, 1, 2, 4, 6. And then I'm determining if this relation is a function. Did X repeat? No, it did not. So yes, this is a function. If you wanted to, you could plot those points and do the vertical line test and see if it fails or not. But I can see up here from the list, from the set here, that none of the x values repeated, so we're good. So that means, yes, it's a function, it qualifies. And that's all it's asking for. So domain is x, range is y. And you can remember that by, this is kind of a silly memory device, but memory devices help. So if you can ever make up memory devices, go for it. D comes before R in the alphabet. X comes before Y in the alphabet. Anyway, so part B, it looks a little different, but we do have a set of points. So we do have a relation. In this table, we call this a table, we have X's and then we have f of x. F of x is just another representation of Y. It is the output when we plug X in. So this is dependent on X. X is independent, Y is dependent. So these are points, 1, 8, 2, 15, 3, 22, and so on. So we could rewrite this as a point. It just looks a little different. So it's just a different representation. So for this, it's really easy to see domain and range because it's just set up right there for us. Domain, range. So go ahead and write that out, domain and range. Determine if it's a function or not. Pause it, try it, come back and check your work. All right, so for domain, you should just get 1, 2, 3, 4. And for range, you should get 8, 15, 22, and 29. X did not repeat, so this relation is a function. I mentioned earlier in the video that we're going over domain and range for discrete functions. And I wanted to expand on that a little bit. Discrete just means just what you're seeing here. We have distinct points that we can see. In a future video, we're going to go over continuous functions, and that's where there's an infinite amount of points in the domain and range, or elements in the domain and range. So these are discrete relations. That means you can easily see and count each point, basically. And so that for that notation, we use the sets there. When we get into continuous functions or continuous relations, we will use interval notation. And so that'll be a different video, but that's what I meant by that. So let's go down to C. We have a graph. We have some points plotted on a graph, and we're still finding domain, range, and then determining if it is a function or not. In this one, you can use the vertical line test since we have a graph already done for us to determine if it's a function or not. For the domain and range, you can either write these out as points if you want to, or you can just use the associated X values that you see on the graph. So pause it, try it, come back. For this one, I did not write out the points, the set of points. I just looked at the X values. Oops, sorry about that. The X values that were used. So 2, 3, 6, and 7 were used. And then for range, I looked at the Y values. We have 2, 3, 4, 6, and 7 that were used. And then if you do the vertical line test, right here, you see that it goes through 2 points, which means that X was used twice. 6 is paired with 2 and 4, which means that it's not paired with a unique Y value or unique element in the range. So this one is not a function. Okay, let's try the next one. This one is called a mapping. So again, another representation of a relation. And I left out the variables here, but typically this is going to be X and this is going to be Y or F of X or G of X or H of X or whatever. So X is the input, Y is the output. Y is what happens when we plug X into our function. And then the arrows are showing where it's mapped to. So -1 is mapped to 5. 0 is mapped to 3, 1 to 5, 2 to 11, 3 to 21. And you can write these out as points if that is easier for you to see. So we have a set of points. Whoops, what did I just write? My brain got ahead of me. There we go. And then 0 to 3, and so on. And then you're going to find, you don't have to write out the points, but if that helps you, you can find domain, range, and determine if it's a function. Pause it, try it, come back and check. For this example, we have the domain as basically the left bubble, -1, 0, 1, 2, and 3. For the range, we have the right bubble, 3, 5, 11, and 21. This one is a function. So in the range, 5 repeated, but that's okay. Our stipulation is that X does not repeat, and X did not repeat, so we're good. This relation is a function. I do want to show you an example of something that would not be a function in a mapping. So we already found that when Y repeated, Y had 2 arrows going to it like that. That's okay. So let's think of, I want you to pause it and think of what a mapping would look like if X repeated. And just draw an example of that. You can use the same numbers if you want to. You can use different numbers, but just draw an example of what you think that would look like. Pause it, try it, come back. I used the same numbers here. Doesn't really matter. You can pick different numbers, but the concept is going to be the same. So basically what happens is if X repeats, we'll just use -1. Then let's say -1 is mapped to 3. And if X repeats, then it's going to be mapped to another number. So you could have picked any number, but I just, to make it easy as far as the arrows go, I just picked 3 and 5. Which means that if I were to write that as points, -1, 3 and -1, 5, that X repeats. So when the V, I guess, is here on the X, then that means it's being used twice. And that's how we know it's not a function. And then you could map the others if you wanted to. 0 can go to 5. 1 can go to 11, 2 to 21, doesn't matter here. And again, this doesn't disqualify it. Y can be used twice, that's okay, but X cannot. All right, that's all I have for domain and range of discrete relations. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help, and I'll see you in the next one. Bye.